In question 1, there are two parts. The first part, we talk about a closed rectangular box has a square base and a capacity of 8, and is to be constructed using this amount of material, and you want to find the dimension of the box. In part B, you have an open rectangular box, and it's still a square base. It still has square base and capacity of 8, and it's to be constructed with this amount of material, and you're supposed to find the dimension of the box. So the difference between part A and part B is one is a closed rectangular box, one is closed, the other one is open. And you shall see what you mean a difference. When you have a closed rectangular box, the base is a square, right? The base is a square. So which means you need to do the cover, right? Because it's closed. So which means you should have 6 faces, top, bottom, plus 4 faces. But so this is for closed, for closed. So you need top and bottom. But for open, you just need the base, because you take it as there's no cover. There's no cover. So it means when you make a box, you just need to build the base. That's good enough. So let's look at the solution and find what's the difference. So you're given the box has a square base. The base is the square. So you let the side be x. So be x, and the height will let be h, the height of the box. So with that, right, you can calculate the volume. Volume is just base area times height. So it's x square h. So it's x square h. And you're given the capacity is 8. You're given the capacity is 8. So which means you just need to equate x square h with 8. And you can make h a subject. H is just 8 over x squared. And because you want to make a box, right, you have to look at the surface area. So for part A, because you have a closed box, so which means you have to consider the base, which is a square, and so the base is a square, area is x squared, then the cover, the top surface, also x squared, so it's x squared plus x squared, so 2x squared. And then the 4 faces, the 4 vertical faces. So you consider the 4 vertical faces, which you open up. It should give you this. So you open up, it should be like this. It should be 1, 2, you should have 4 of them. Then this is x, and this is h. So it should be 4x times h will give you the 4 vertical faces. So let's have 4xh. And we just found a relation between h and x. H is 8 over x squared from the fact volume is x squared h and capacity is 8. So with that, you can replace h by 8 over x squared, and eventually the surface area A will be just 2x squared plus 32 over x. So from here, you do differentiation to minimize area. So you differentiate to find dA dx. Differentiate 2x squared will give you 4x. Differentiate 32 over x will give you minus 32 over x squared. And then you set dA dx to 0, which is same as 4x equal to, you can just say, because it's equal to 0, so it's like you bring it to the right hand side. So that's why it's 4x equal to 32x squared. and then you can cross multiply. You can cancel 4 and 32 to give you 8. X squared you multiply to the left hand side, so become x cubed equal to 8. So x will be cube root of 8, which is 2. And then you can find the second derivative to show minimum. Differentiate 4x will give you a 4. Differentiate 32 over x squared will give you 64 over x cubed. And then if you sub x as 2, you give you 12, which is positive. Positive will imply minimum surface area, minimum area. And then you must answer the question. The question asks for find the dimension of the box which uses the least material. You want to construct this closed rectangular box using this material, and the question asks for the dimension of the box. So you have to answer the question. So you know it occurs when x is 2, and then you can find the height. You know the height. The height is 8 over x squared. So 8 over x squared. Sub x as 2, you get 2. So which means to minimize material, you build it as a cube. Base 2, then breadth height or 2. Next we look at part B. Part B, this time we look at open, so there's no cover, which means you just need to consider the base which is x squared, and the 4 faces. So the difference between part A and part B is the surface area. You have x squared lesser, it's just x squared. Previously you have 2x squared. Previously you have 2x squared. And then same thing, you differentiate to find dA dx. Differentiate x squared give you 2x, and this give you 32 over x squared. If you set dA dx to 0, of course the x value will be different because here is x squared instead of 2x squared. So it will be 2x equal to 32 over x squared. You can cancel to give you 16. So it gives you x cubed is 16. X cubed is 16. So x is cube of 16. 16 is 2 cubed times 2. So you can take cube. So if you take cube root, it should give you a 2 for this term, and then a cube root of 2. That's why it's 2 cube root of 2. And you can differentiate to find second derivative, and sub x as cube root of 16, you'll find that there's 6, which is positive. So by the second derivative test, it tells you that the surface area will be minimum at x equal to 2 cube root of 2. And then you can solve for h. H is still 8 over x squared. H is still like the previous case, is 8 over x squared, because you consider same capacity. You consider same capacity 8. So that means it's still h equal to 8 over x squared, because you still consider x squared h equal to 8. And then you can work it out, it should give you cube root of 2. So that means this time you should make it with the height is lesser, height is just cube root 2, but the base is 2 cube root 2. So the base is longer, the height is shorter. So that's the difference between part A and part B.